No, sono quelle attaccate. We just started the direct on YouTube.
Okay, thank you, Mia, for the updating.
Ci appoggiamo. Quindi, sì.
Okay, so hi everyone. This is the first of a series of seminars to pave the way to Touching the Sky, our project. The seminar replies to a simple and very powerful question. Which sky does a student from Novi, from Stirling, and from Afghanistan see when they look up at it? Dr. Bernagozzi will guide us through constellations and traditions from the sky. The same sky above Italy, Scotland, and Afghanistan, observed and told with different stories. A meeting between science and culture to discover that we are all under the same sky, whose title is Science Beyond the Cultures. When the Afghanistan school is ready, we can let them speak, okay? They have got a short presentation if they're ready. If they are not ready yet, I think that we can start with Dr. Bernagozzi. Okay. Dr. Bernagozzi, if you want, you can start. Okay, thank you.
Thank you. So uh, I'm very excited to be part of this event and because it's something very special for all of us, I think. And my name is Andrea, and I am a researcher at the Astronomical Observatory of the Autonomous Region of the Aosta Valley in Italy. And now I'm going to share my presentation. Okay, I hope that everyone can see my presentation. So, buongiorno in Italia, good morning in UK, in Scotland, and salam alaikum in Afghanistan. I hope to have said something that is correct in this language. That is not my language. So, thank you so much for everything, for the organization of this wonderful meeting. This is a picture of the stars that we can see above our head at the Astronomical Observatory where I work in the Aosta Valley on the top of a mountain here in the northwestern Alps in Italy. And this is a wonderful sky full of stars. And during this presentation, I will try to show you through a simulation made with a software, with a computer, and in which way we can look at the sky, at the stars, from Italy, from Novi Ligure, from Stirling in Scotland, and from Afghanistan. This is why this presentation, this lecture, this meeting is called Under the Same Sky, because we are looking at the same sky that is the same for all of us, but our point of view can change because we live in different parts of our planet, the Earth. This presentation is possible also thanks to some institutions helping us to do this work, the Autonomous Region of the Aosta Valley, and also the Unité of Comune Val d'Othè Montemilius, and the town administration of Nus, and Fondazione CRT in Piedmont. Okay. So, I beg your pardon in advance for my English. I'm not very good in English, so I will speak a very basic English. Also, because in this way, I hope that everyone can understand what I want to say. And this is a picture or the place where I work. We are here in this astronomical observatory. Here we have the telescopes with through which we can look at the stars. This is the small village of Lignan, a village of the municipality of Nus. And you can see also the Alps around us. We are in a valley among mountains, so we have a big part of the sky that is above the mountains, and so we can see a lot of stars. Here we can see also another dome. In this white dome, we have our main telescope to perform research observations. Here we have the planetarium, where we can we can use projectors to show the stars that are made with the computers. It is a digital sky that we can project on the dome when we want to show you a reconstruction of the starry night sky. This is a simulation of our view. You can see the telescopes of some of the several telescopes that we have in our astronomical observatory. And this is the view made thanks to the collaboration of the astronomer Anna Elisa Kamisaska. And this is a simulation of the view from our astronomical observatory at 11 a.m. of this morning. Okay, we can see that there is the date now, 2026, February, the 20th day of February, 11 in the morning. So we can see the sun, because it's the sun is above the horizon, so it's daytime in this moment here in Italy, and also in Scotland, and I believe it's afternoon in Afghanistan. We are looking at the sky, the same sky for everyone, but from different parts of the Earth. We are here. This is the red arrow, can show you where the Astronomical Observatory is here in this map of the Earth. We are not so far from Novi Ligure, that is in Piedmont. The red arrow now is showing you the location of Novi Ligure. That is not far from us, so it is not very different, the position of the arrow. But if we go in Scotland, okay, now we have changed our position a lot, because we are in another part of the world. Stirling is farther north with respect to Italy. And obviously, there is also the position of Afghanistan, that is farther east and south with respect to Italy. So these are the different places from which we are going to give a look at the sky, thanks to this simulation made with a freeware, a free software that if you want, you can download and use, that is called Stellarium. And it is very easy to use it. And it is a very powerful instrument to have a reconstruction of the sky. You can choose the place where you are, sorry, to from where you look at the sky. You can change the date, you can change the hours, and so on. So now let's go back to Novi. This is the theoretical horizon of Novi. With this green section, we are representing the ground with no mountains, with no buildings. In this way, we have all the sky that we can see from Novi Ligure in Piedmont that is visible from our point of view. So it is a synthetic sky, but this is the vision. Obviously, the hour is now 11 a.m. in the morning, and the date is today. We can see that there is a sun. There is also the moon that is not very visible because it's daytime. So there is the light of the sun, and the sky is blue because of the light coming from our star, the sun. The sun is very bright. Please remember, never look at the sun with your eye without filters or some kind of protection, because the light coming from the sun is very intense, very powerful, and we can also have damages to our eyes. So be very careful with that. Here we have no problem because this is a picture made with the computer. So no problem at looking at this star here in the picture. And thanks to the software, we can also move us forward in time. So now it's night. It's 9 p.m. here in Novi Ligure in Piedmont, and we can see the stars. There are also the name of the stars. Here I want to show you this star that at 9 p.m., so this evening, is very close to the south cardinal direction, okay? And this star is Sirius. Sirius is the star that is appearing to our eyes as the most brilliant star that we can see with the naked eye. If we travel all around the world, from the Arctic region to the equator to the Antarctic region, and we look at the stars from every part of the world while the Earth is rotating around its axis, during the night time, we can see with the naked eye more or less 5,000 stars, okay, with the naked eye. Obviously, with the telescope, you can see a lot of stars that are not visible with the naked eye. But only with our sight, we can see more or less 5,000 stars. If the night is clear, if there are no clouds, if there is no full moon, if there are no artificial lights blinding you, and so on. Okay. And Sirius, among all the stars, is the one appearing most brilliant to us. And please take notice of the position of Sirius with respect to the horizon. It's very close to the horizon, in the direction of the southern part of the horizon. Now let's travel from Novi to Stirling. Same moment. Okay, we are noticing first that the date is the same, but while it's 9 p.m. In Novi, it's 8 p.m. in Stirling. We have changed our position on the Earth, so we have changed also the time zone. And when it's 9 p.m. here in Italy, it's 8 p.m. in UK. And this is a first consideration. Second, please notice that Sirius is rising from the eastern horizon. Here we are in Italy, in Novi Ligure, and Sirius is above the southern direction. Here we are in Stirling. In the same moment, it's rising from the eastern horizon. So it's closer to the horizon. Is this strange? Not at all. We have changed our point of view because we have moved on the surface of the Earth. So there is nothing strange in the fact that changing our point of view, we can see things differently. And while Sirius is higher on the horizon in Italy, it is still rising in Stirling, in Scotland. And obviously now it's time to go to Afghanistan. And in the same moment, we can see that Sirius is setting. It's closer to the western horizon. Is this strange? Not at all. For the same reason as we have said before, we have changed our point of view. We are looking at the same sky, but from different positions. So we can see things in a different way. We can also notice that in the same moment in which is the evening of today, the 20th of February here in Europe, it is already the night of tomorrow in Afghanistan, the 21st of February. And this is because the Earth is rotating and Afghanistan is farther east with respect to Europe. And so it is also changing the time zone. But we want to give a look to Sirius also because I have noticed that there has been a comment by someone, I believe from Afghanistan, writing that Sirius, the dog star, it is also called the dog star, is one of their favorite stars. So let's travel back in time. We are in Afghanistan, but now when it's 9 p.m., when it's evening in Afghanistan, and we can notice that we can see Sirius above the southern horizon, and it's very brilliant, so it's very easy to notice it. And there is also another dot tonight that is very brilliant, that is above Sirius. We can see it in Novi Ligure, in Stirling, and also in Afghanistan, but this is not a star. This is the Jupiter planet. It is a planet. And it is very brilliant because it's orbiting around the sun together with the Earth. So it's not so far from us. And Sirius is a star that is very far from us. So the most brilliant object in the sky tonight is Jupiter, the planet, but the most brilliant star every night when it is visible from the Earth is Sirius. And these are the stars, and the stars have inspired our ancestors that have given a wonderful present to us. And what is this present? What is the legacy that we have received from the past, thanks to our ancestors, to people that has lived centuries, even millennia of years, even centuries and millennia ago. This present is the sky full of constellations. The constellations are these imaginary drawings, these lines with which our ancestors have fulfilled the sky, connecting the bright dots of the stars one with the others in pictures that are not real. These lines are not in the sky. They have been invented so that we can, in a certain sense, play with the sky. I believe that many of us have played when it's daytime and we can see a cloud, and we have played with the clouds, and we, with our imagination, have invented the shape of the cloud. This cloud is resembling a dog, a cat, a fish, everything you want. Okay, this is a game, obviously, because it's our fantasy, it's our imagination that is letting us to see these animals or any other things in the clouds. We know that these are clouds and there are no dogs, cats, fishes, and so on. The same is with the constellation. We are playing with the sky. This line connecting the stars have been invented by our fantasy, but our imagination. And with these lines, we can also have pictures like the clouds. These lines can give us the idea of something, of creatures, fruit of our imagination, but that we have projected in the sky. So we can see why Sirius is called the dog star, because is in the constellation of the dog, the, the larger dog, the bigger dog, because there is also the lesser dog that is another constellation. And this is the constellation of a giant going hunting in the wild woods. This giant has been called Orion. So we have the dogs and Orion, the hunter, here in the sky. And this is the vision from Afghanistan, 9 p.m. this evening. Oh, but something has changed. These are not the same pictures of constellation that we have seen before. Yes, because these are the pictures of the constellation according to the Western tradition, to the tradition, the cultural tradition of Europe, and these are the constellations that 1 century ago have been classified by the astronomers of the world to use this constellation when they perform their scientific research. These are the constellations that have been pictured, by an astronomer of 1 millennium ago. The astronomer Al-Sufi, a Persian astronomer that has written a book called The Book of the Fixed Stars. We can translate like the Book of Constellations, according to the Islamic tradition. The name of this book in Arabic language, more or less, should be Kitab Suwar al-Kawakib. I'm sorry, I can't speak Arab very well. I can speak English very well, and you can imagine with my Arab. And in this way, we can see that there are some constellations that are very similar to the constellation of the Western tradition, but they are pictured in a different way because they are pictured according to the Islamic tradition. And we can see again that Sirius is in the constellation of the dog, but now Orion, yes, if it is still a giant, but the name of this giant, one of the many names that this giant can have in the Islamic tradition, is Al-Jabbar, the powerful giant going hunting in the sky. So same stars, but a different imagination, because people is different. Every people, every person in the world has her imagination, his imagination. So when we look at the stars, we can imagine different pictures, or if we imagine more or less the same pictures, we can call these pictures with different names. So same stars, but a lot of different cultural traditions, and every tradition with the same aim, with the same goal: understanding the beauty of the night sky and help us to know the sky in, thanks to the constellation, so that we can understand which part of the sky we are looking at. If it's winter and it's the start of the evening, and we can see the constellation of the dog, then we can understand that this is the direction of south. So we are looking at south. So the constellation can help us to understand the cardinal direction around the horizon, if we know the constellation and if we know the time at which we are looking at the sky. And also the stars can help us to understand these pictures. This star on the shoulder of Orion, according to the Western tradition, is called by Al-Sufi in his book of the 10th century, 1000 of years ago, is called Yad al-Jawza, more or less. Please, I beg your pardon for my arm. And that means the hand, because it is close to the hand of Al-Jabbar. And this other star that we call Rigel in English, we can also call it Rigel in Italian. The same name with different pronunciation, but the name Rigel in English, Rigel in Italian, is an interpretation, a Western and a European interpretation of the name Rijal Jajwal Yusra, that means the left leg, the left foot of the giant. And in fact, we can notice that in this picture, it is corresponding to the left foot of Al-Jabbar. So the name of the stars, Rigel, the left foot, Betelgeuse or Betelgeuse, Betelgeuse in English, Betelgeuse in Italian, they are the Western name, the official name according to modern astronomy of the stars, but their origin is very ancient, because these names have been invented in the Middle Ages by Arab astronomers, by Persian astronomers. Then their tradition, their knowledge has been handed down to our tradition, and so we have received this wonderful present, the name of the stars, from the thanks to the work of people looking at the stars from the Arabic Peninsula, from Persia, from the territory that now is Afghanistan. And we use these names today to perform astronomical research. So this is very important. This is a tradition that is transmitted across the centuries, across the borders, across the continents, across the ages. This is something that I find very wonderful for astronomy, because looking at the star, we can connect not only with the star, with the sky, but also with the knowledge of all the people that has looked at the star before us. And this is very important. And this is not only a romantic connection, it is a cultural connection and also a technical one, because here in modern astronomy, we still use this tradition to point our telescopes. Let's point our telescopes to the constellation of Orion. Let's give a look at Betelgeuse. We are Betelgeuse. We are using today this knowledge, obviously with the modern instrumentation, with the modern knowledge, but this modern knowledge is an integration of the ancient knowledge. Now let's change our point of view. We are in Afghanistan, still in Afghanistan, but we are looking north. And we can see that here in the northern part of the horizon, when it's 9 p.m., we can notice two very famous constellations that are very famous all around the world in the northern hemisphere of the Earth. We can see the larger bear that we in Italian call the Orsa Maggiore, and the lesser bear, the Orsa Minore in Italian. And now I will try to read the name of this constellation according to the Book of Fixed Stars by Al-Sufi, by the Persian astronomers. The larger bear is Surat al-Dub al-Akbar. Akbar means, I think, the larger. And the lesser bear is Surat al-Dub al-Ashgar. These are two constellations that are very important. Why they are so important? Because here, at the end of the tail of the lesser bear, by the way, bears have not such tails. These long tails are fruit of imagination. If we are playing with the sky, let's play with fun. So our ancestors have invented something that we cannot meet on the Earth. Birds with these very long tails. This is a way in which we can also remember the name of constellation, because they are different from the real birds that we can meet here on the Earth. Okay, so these are the long tails of these birds are a very simple example of how important is imagination in the exploration of the night sky, in the invention of the constellation. So this star at the end of the tail of the lesser bear is very important, because this star is the Polaris star, the North Pole star. It is a star that is more or less above the North Pole of the Earth. From Afghanistan, we can see that it is in the north direction, but it's at a certain distance from the horizon. It's not very high. Here we can see also the degree of the high altitude of the star from the horizon. It is more than 30 degrees. Why this is important? Because let's give a look to the map. We are looking at Afghanistan. Okay, 9 p.m. Now, Here we're still in Afghanistan, and we are seeing that this star is very important because from our point of view, from the Earth, this star is more or less always in the same point of the sky during the night. It is not changing the position. It is not rising. It is not setting during the night. It's always there because it's above the North Pole of the Earth. Earth is rotating around its axis, and from our point of view, the Earth, this star is by chance above the North Pole. So the Earth is rotating around an imaginary axis that from the Earth is going to this star, to the pole star. So this is a fixed point in the sky. During nighttime, all the star seems to move around, circling the North Star. This is an illusion because it is the Earth rotating in the other direction, like a merry-go-round. We are on board in this merry-go-round, and we have the illusion that is the sky that is rotating around us in the other direction. But the pole star is a reference to us because it is always in the same position in the star. So when we see the pole star, we can understand where the northern direction is. So this is the position of the North Star seen from the Afghanistan, and I have chosen the position of Kabul. And if we change our position, now we are here in Italy, in Novi, and you can see that the star is moving. But why? I have just said that this star is still in the sky. It's always in the same point. In fact, the star is always in the same point, but we are changing our position on the Earth. We are moving from Kabul to Novi Ligure, from Afghanistan to Italy, to northern Italy. So we are closer to the North Pole of the Earth. And from our point of view, the North Pole star is higher. The altitude is larger than from Kabul. In fact, we can notice that with respect to the horizon, it's 45 degrees. 19 degrees is exactly above our head. But this is the position above our head of the North Star if we are on the North Pole of the Earth. Kabul is closer to the equator than Novi Ligure. Novi Ligure is more or less midway between the equator and the North Pole of the Earth. So we can see the pole star midway in the sky, not near the equator, not above our head. 45 degrees of altitude with respect to the horizon. And if we go to steering, we are going north. So let's think. Should the pole star look closer to the horizon or farther to the horizon if we go from Novi Ligure to Stirling, Scotland? 3, 2, 1. I hope that you have thought your answer. We are going closer to the Arctic region, to the North Pole of the Earth. So the pole star is getting higher. And we can see that the altitude is 56 degrees. 11 degrees more than from Novi. So let's recap. If we give a look at the pole star in the sky, we have several information. Two of these information are: first, we can understand where the northern direction is. Second, we can understand also our position on the surface of the Earth. Kabul is closer to the equator than Novi Ligure, and Stirling is closer to the North Pole than Novi Ligure and Kabul. So we can understand why our ancestors, why the ancient people has invented the constellation, not only because of the beauty of the constellation in the starry sky, but also for practical reasons. Because if you know the constellation, you can find the pole star, and if you can find the pole star, you can understand where the northern direction is here on the surface of the Earth. So you can decide to move north, south, east, or west. And you can also understand in which part of the Earth you are. Close to the equator, close to the North Pole of the Earth, or every place in the among these two special regions of the planet. So the constellations are a wonderful present, as I said before, because they are very amusing, because they are very fascinating, because they are telling us something about the imagination and the stories and the legends and the myths that have been invented by ancient people that has lived centuries and millennia ago, but they are very useful too, because thanks to the constellation, we can also have a lot of information that are useful to us here on the surface of the Earth, on the Earth. So now we are near to the end of this presentation, and we have traveled in time for all of us. We are in summer now. You can see is 6 months from now. We are in August, according to the Western calendar, obviously. And we are looking at the night sky at 10 p.m. And at 10 p.m., if you are in Kabul, if you are in Novi Ligure, if you are in Stirling, during summer, above our head, we can see these three wonderful stars. The star of the so-called summer triangle, the star Altair, the star Deneb, and the star Vega. By the way, these names are of Islamic origin. They have invented by the Islamic astronomers during the Middle Ages. And these are stars that today, according to the modern classification of constellation, are in three different constellations for the astronomers. And Altair is in the constellation of the Eagle, Surat al-Ukab, according to Al-Sufi. Vega is in the constellation of the little harp, a musical harp, the harp with which you can play music and sing if you want. Surat al-Shulyak, according to the name of Al-Sufi. And Deneb, it is the tail of the constellation of the Swan, Surat al-Dajaja. I beg your pardon again for my pronunciation in Arab. And there is something that is very funny about this constellation, because according to some tradition of the Islamic cultures of the past, this constellation is the constellation of a bird, but not a swan, a very beautiful and elegant bird flying in the night sky. No, this constellation is again is a bird, but a chicken. But this is very strange. This constellation is a swan. Is this constellation a swan? Is it a chicken? But we have said before, constellations are invented by us, and everyone has a different imagination. So, in some part of the world, for example, the ancient Greeks, they have decided that in this group of stars that they have connected with lines, they can see a swan, a beautiful swan flying in the sky above us during summer. And in another part of the world, it is the chicken. Maybe that a chicken is not as much beautiful as a swan. Obviously, everyone has her taste or his taste. So, but it is a very important animal, a very important bird, because it is very important, for example, for food. So it is, and the swan maybe is nobler, but it is the chicken that help us to eat. So it is very important to homage also the chicken in the sky. And the little harp, the constellation of the Lyra, this is the name in Latin that is used still in modern astronomy. Latin is the language of the ancient Romans that has lived here in Italy many centuries ago. And the little harp, you can see the, the picture of this little harp. Okay, if we go back to the book of fixed stars by Al-Sufi, we discover that Al-Sufi hasn't drawn an harp, but a tortoise. But this is very strange because this is very different. A chicken, a swan, but they are birds. But in which way we can imagine a tortoise when other people has imagined an harp? No problem. First, we are free with our imagination to see what we want. You can imagine your own constellation if you want here and with all the other constellations that are in the night sky, because they are fruit of our fantasy. Obviously, if you want to do astronomy, then you should use the constellation, the 88 constellations that have been classified by modern astronomers, because we have the need to exchange data, to exchange measures made with the telescopes. So we should call the constellations in the same way. And I can't call the constellation with my imagination. I can't give a name invented by me, because I have to show my research to all the astronomers in the world. So we should have a common ground in the sky, no pun intended, a common ground in the sky. So we should have a common division of the sky in 88 constellations so that we can exchange data. But if you want, you can invent your own constellations. Tonight, every night, all along your life. But we have also to say that there is a connection between the tortoise and the harp, because in the past, the harp was made with cords, with strings attached to the body of the tortoise. So when we are moving the strings of of the harp. We can listen to the music thanks to the body of the tortoise, the shell of the tortoise that is resonating with the vibration, making our music. So it is very different. An harp, sorry, is very different from a tortoise. But we can see that even in this case, we can find a connection. And this is uh, the most important things of looking at the night sky. We can invent different constellation. We can have imagination, and every culture from every continent in every period of the human history has invented different constellation and has given different names, a different name to this constellation. But these constellation are in the sky above us, a sky that is above all of us. We can see at the sky in different ways, according to our tradition, according to our position here on the earth. But looking at the sky, we are connected one with the other because all of us are under the same sky. And when tonight I will look with the telescope for our astronomical from our astronomical observatory to Sirius, you too, if you want, can look at Sirius at the same moment or during the night. And in this way, we can connect each other, even if we are far from us in different parts of the world, because we are looking at the same star and we have those stars in common. And not only in common among us living on the earth today, but also in common with all the people that has lived before us, giving us this wonderful tradition of this wonderful invention of the constellation. And also we are already connected with the people that will live in the future, because we are transmitting our knowledge to the future generation as exactly in the same way in which our ancestors have handed down their knowledge to us, a knowledge that we are using today in modern astronomy. So I have finished my presentation. I thank you for your attention, for your patience, and for your uh, good spirit with my terrible English. And if you have the opportunity, these are some links through which you can download this application Stellarium, so that you can choose your position and see the sky from your side of observation with the PC, and also scientific and cultural information about the 88 constellation that we are using in modern astronomy. So thank you so much.
Thank you a lot. Your English was not bad at all. Do not worry. It was an amazing and powerful presentation. It was so interesting, full of history, of science, also of imagination, as you said. I see that our colleague has asked to speak. Pashtun, you can go.
Yes, thank you so much, Dr. Andrea, Maria, and Corrado, for this awesome opportunity for our students to join in and explore the secrets of the universe and the constellations. Sorry, we are facing technical difficulties with presenting our presentation at the moment, but we have Yalda Walizada that wants to share her thoughts on the skies of Afghanistan at the moment. And I will give floor to Hadia Walizada. Go ahead.
Thank you.
Okay, so hello everyone. I hope you're doing well. So first of all, I would like to mention that we were informed that our presentation would be on April 1st. So for today, I want to brief present some information. Um, so as you said, as may you know that I'm from Afghanistan, and my presentation is a little bit about Afghanistan culture, Afghanistan, but what people of Afghanistan think about the moon, or this subject. So in Afghanistan, some people believe that the moon has an effect on a culture and daily life. For example, it is believed that the moon influences farming cycle and traditional farmer thinks that the timing of the moon, especially its phases, can affect when crops grow best. Some planting is done when the moon is waxing, and because people believe plants will grow stronger during this period. And also, there is a cultural belief that dreams seen under a full moon have a special significance, and many people think these dreams are more meaningful and may provide guidance for life decision. So let's talk about its shape. I mean, the moon shape. You may notice that sometimes the sky becomes dark and the moon is not visible. It is called the new moon, and in Afghanistan we said mah geriftegi. That the moon does not actually change its shape, and instead its phases happen because of the moon's orbit around the Earth, and the moon moves the angle between the Earth, moon, and sun changes. When the moon is between the Earth and Sun, we can barely see it. As it continues moving, more of its illuminated side becomes visible until we see a full moon. After that, it gradually decreases again. So the phrases are about perspective, not a physical change in the moon. And there is a scientific fact that the scientists have discovered that the moon is slowly moving farther away from the earth, and many people believe that over millions of years, not now. This will cause Earth rotation to slow down slightly, meaning our days will become a little longer, and tides will also change over times. However, this is a very slow process, so no major change will happen anytime soon. And another important scientific fact is about the origin of the moon. Scientists believe that the moon formed about 4.5 billion years ago after a giant uh, collision between the young Earth and a Mars-sized object. And before that event, the moon did not exist. So, as I mentioned earlier, we were informed that our presentation would be on April 1st. So, today was not our main presentation. Because of that, we have not yet fully collaborated on our information, and we do not have slides prepared. So, for today, just I briefly introduce the topic, and thank you attention.
Thank you, Hadia Walizada, for this awesome, experience that you have earned. Thank you so much. This is a small thing that we contribute to science from our side and try to make sure that we stay intact with the world than what we teach our students. So that's from my side, from my school. Yeah, I just want to give the floor to Maria. And again, thank you, Corrado and Andrea. Thank you so much.
Thank you. That was a great presentation. Thank you so much. And now I think that we can also ask our Scottish students if they want to give just a short presentation of themselves, because it's the first time that we meet with the Afghan school and colleagues. Just to say hi. what you're studying, and so on, like you did last time with us. Just a short presentation. Okay, thank you so much. Yes, you need to put your microphone on. Thank you.
We all faced technical difficulties. It
Always.
All of
Always.
us.
In fact, we prepare beforehand, let's say an hour before the meeting, because yes, the problem is always around the corner. We know. Oh, now it's working. Thank you. Working.
Hi. Hello, we're from Wallace High School, Stirling, Scotland.
Thank you so much for the presentation. We find it really, I think we all find it really interesting. It's really, I personally find it really interesting how like culture and like different kind of traditions like impact the way we see the night sky. Like I thought that was a really like, I've never thought about it that way before. Like that was a really like interesting angle to learn about. I think I really enjoyed that. We all do physics at school, and one of the topics we study in physics is about space. I find that really interesting, but it's nice to like, instead of just doing like the maths and equations, sometimes I feel like you can kind of lose sense of the bigger picture. So really like that presentation, like kind of, I don't know, like the more exciting part of space that's not like calculating like light years and things. Like I feel like it's gonna remember what like physics is actually about, and like how you actually apply it just outside of the classroom and just doing like questions. It gets like repetitive. Like I think we all find that really interesting. Like,
Yes.
what did you guys find interesting about the presentation?
Wow, you covered everything, didn't you, Nora? Yes. I found it very interesting how the qualitative aspects of space and how it's been impacted by cultures over thousands of years, and how they're still impacting how we see the stars today.
I think it's also really interesting, like when you look at the different like the two different pictures of the constellations, like how a lot of them are like quite similar. Like people can see the same like animals and like figures. I think that's really I just find it really interesting how like people like, despite being from like different like parts of the world and having different culture, can still like imagine the same type of things, and also like imagining different things. I find that I think we all find it really interesting, and I think it was like thank you so much. I really enjoyed that.
Thank you. That was great. And this is the first time ever for us, but I think also for you, that 3 countries are connected under the same sky and under the flag of education, right? And freedom of education for everyone. So we are connected by this powerful event, the first ever, and we are really so excited and thrilled to be part of this project. And we thank you from the deep of our heart of being part of this great project. Thank you so much.
Thank you.
Thank you. Have you got any questions? Yes, please go.
Yes, first of all, if I can speak only 1 minute, I want to introduce my colleague Erika. Okay. Hi. She is an astronomer.
Erika.
Okay. She's an astronomer. She's younger than me. She is better than me as an astronomer.
Can you please show yourself? Thank you. Hi, Erika. Nice to be with us. You're welcome.
It's very cool, this initiative. It's very, very heartwarming.
Heartwarming.
Thank you.
She can speak English. She can speak English better than me too. And this is the first thing that I wanted to say. I want also to add about a comment from the Scottish school. Yes, it is very important to notice that some constellation, even if invented by different people in different parts of the world are very similar. This can be explained with the two reasons. First of all, we are human, so we have the same needs and we have the same dreams, the dreams of the full moon that have been quoted, that have been evocated by our the presentation, the beautiful presentation from Afghanistan, from the moon, but also because we are under the same sky and exchanging views of the same sky. So in our history, we've also exchanged our imagination of the constellations, and we have influenced one with the other, and we have established connections between different cultures thanks to the stars. And this is something that is very important, because it is an important lesson that we as astronomy, we are trying to put in practice even nowadays. Okay, I have finished. Thank you.
I think so. One of our
Yes, there
students
is
has
a
a question from you.
question.
Yeah, Zahra, go ahead.
Hello, I hope you are doing well. So I have one question from Mr. Andrea. I hope you understand my question. Also, my English isn't very good. So my question is that are constellations close to each other in space, or do they only appear close from our point of view on Earth?
Sorry. Okay. I have asked Erica to join me so she can understand the English better than me. So, if I well understood, the question is about the physical nature of the constellation. They are only a fruit of imagination, of there is a real connection among the stars. No, the constellation have no physical nature. The stars in the same constellation are in different parts of the cosmos from us at a different distances, and it's only a matter of perspective. From our point of view, we see those stars one close to the other in the sky, but they are one after the other in space. So there is nothing in the universe like a constellation. Obviously, there are sometimes stars that are in the same part of the cosmos, one close to the other. But if we are talking about the constellation that we see with the naked eye, these are very few exceptions. Okay, so the rule, the main rule, is the constellation are invented. They have no physical reality. However, they are a wonderful example of imagination. And even if they are not real from the point of view of astronomy, they are real from us as human beings. And the fact that we are talking about constellations this morning, and we have talked about constellation invented by the Greeks, by the Romans, by the Persians, by the Arabs, and by all the peoples that have lived on our earth. This is something that can let us understand that the real meaning of the constellation is something that is something that is about the human beings more than the stars. With the invention of constellation, we are talking about our values, what is important for us, what we have decided to honor with a constellation. So the swan or the chicken, it's the same. Obviously, it's not the same from the point of view of the animals, but the same, it is the same purposes. In this period, that those people have decided to, that for them, a swan was important, for other people in other period, a chicken was important, and so on. So constellation is, the constellation are, sorry, something that can explain more about our human nature than about astronomy. Then we can study with the telescope the stars in the constellation, and we can also understand the physical nature of the stars. But this is the science behind the constellations.
Okay, thanks a lot. From Italian students, any questions?
Hi, yes, we have some question.
Thank you.
I'm Zineb, and how can we bridge the gap between complex scientific research and public understanding?
Is this a question for me?
Yes.
Okay. How we can bridge this gap? But first of all, I will ask also to my colleague Erika if she wants to give her 2 cents about these very important and big questions. Big question. It is not easy to bridge a gap because science is something that is very complex, is very difficult. You have to study a lot. You have to have a lot of technical knowledge if you want to go deeper and deeper in science. But science is made for the benefit of humankind. Understanding the world in which we live, understanding the cosmos, is something that can help us all to live better because we know our position in the cosmos, for example. And this is a reason for which our Astronomical Observatory is very committed to also public education and outreach of astronomy. And I don't know if Erika...
Yeah, following on this, I think one of the main challenges in bridging the gap is that scientists had to study so much for so long, so deep into the knowledge, that they forget what was the basis they started from. And so the most difficult part is to clean up kind of their brain and start from the beginning. So I think talking continuously to the students, to the population, to people that are just curious, and ask them, okay, what do you know? What do you want to learn? And remembering, oh, that person is curious about this. I give this for granted, but for this person, this is not for granted. Let me explain this thing that I maybe didn't know it was so important for them, but it was. And so I think that just keeping this bridge open, organizing things like this, and have a lot of events and opportunities to have scientists and people meet, it's very important, because it's a matter of finding again the common language and to remember what are the questions that are important, because it's very easy, I think, for a scientist to just lose in the papers and in the mind. But it's important to remember, yes, we do this for the community. So what is the curiosity of the community? What are people passionate about? Let's remember what are those questions.
Thank you, Erika. In fact, this is the main goal
so
of
much.
our project.
So thank you
Okay,
again
who's
for
next?
organizing this.
Thank you.
STEM.
Yes, that's it. Who's next?
I have a question. My question is, astronomy often requires years of data collection before a discovery. So how do you stay motivated during the process?
This is a wonderful question. So we have to work for years, eh? In certain cases, also dozens of years before a discovery. So, please think if you want to add something to what I'm going to say. Okay, the motivation. First of all, there is the motivation of understanding the world. Because understanding the world is something, why it is so important to understanding the world. Because we are not people going to a theater to see a show that is on the stage. We are part of the world. We are here on this planet, orbiting a star, among a lot of other stars in a certain galaxy, because of the several physical, chemical, astronomical processes that have shaped the universe in which we live, the universe to which we belong, the universe we belong to. So understanding is a prize, is a reward. Even a little bit of understanding of the world is a reward, because we are understanding better who we are. And so this is a strong motivation. Even when you are doing a research and you know that probably the results of your observation will be understood 30 years in the future. And I have known astronomers that have died before the research that they have started had given the results. And this is something very moving for me, because it's more or less like our ancestors and us. We are passing our baton, like the race, like the race in athletics. We are passing our baton to the people that will carry out our research after our work. And this is the same things that Al-Sufi has done with us, for example. He has passed us his baton about the study of the constellations. Erika.
Yes, and also on this, it is not that maybe a long mission will give you out the data just 10 years after altogether. There are different stages in preparing a mission and also in what a scientist can do. So from one point of view, we kind of often have the opposite problem. We would like to have more time to prepare for the mission, and because you want, first of all, there is a lot of work before the mission starts, because you kind of have to set the same ruler to collect the data, and this is always not easy, because a lot of people may predict different observations, and so you have the first step that you have maybe different predictions. So you're really curious to see what are the observations that could confirm your model. So it is not a problem for you to have a few years to wait for the confirmation of your theory. You have years to improve your theory. So it's not that you are bored. You have something to do while you wait for the data. And then the data arrives, but maybe it does not arrive altogether. For instance, there is a mission, Gaia, that has finished a few years ago, that every 2-3 years releases a bit more of data. So in every release, a lot of scientists are very happy because they can find a lot of information and they start to dig into the data and they find a lot of answers to some questions, but often they find even more questions that drives them even more curious. Okay, I wanted to wait the next 2-3 years and see the more data that they will come. And so in those 2-3 years of gap, they have a lot to do, really a lot of questions that are drove by the new data. And so it's really a matter of just managing better the time between those data releases and the preparation. It's fun because it's in reality, it's kind of the opposite, the problem. We are really too curious.
Please learn from Erica. She has got a lot of motivation. You can experience.
We can feel it. We can. Thank you.
Thank you very much.
Hello, I wanted to ask, is the right to see the stars, which are we are losing a lot of dark sky due to urban light pollution, and is the right to see the stars something we should fight for as a human right?
Okay, this is a wonderful question. All these questions are very important, but it's funny because yesterday, not a lot of time ago, but yesterday afternoon, I was talking exactly from the same place where we are now with a colleague of mine that is the president-elect of the American Astronomical Society in the United States, exactly about this problem. The fact that due to the artificial lights that are a wonderful invention, but they should be used to send light to the ground where we walk to see, and so we have the need to see where we walk, and artificial lights in many cases are sending light also towards the sky. And this means that we are no more able to see all the stars that are in the night sky, because we can see the stars. We can see the stars because they are brilliant dots and with a dark background of the night. But if the night is illuminated, this background is not dark anymore. And so we are losing the faintest stars. This means I am from Milan, that is a city here in northern Italy, where there are the Winter Olympics in this moment. And in Milan, in the night sky, you can see 20 stars with the naked eye. While here at our Astronomical Observatory, where there are no clouds and there is no full moon, you can see in the same sky 2,000 stars. This is a phenomenon called light pollution that now is even worse than a few years ago, because we have another source of light pollution that is not connected to the artificial lights, but to the increasing number of artificial satellites orbiting our Earth. This is a very important topic that is very difficult to explore in few minutes, in few seconds, and only to let you know how it is important for us. Yesterday we have written to the Federal Commission of Communication, that is the federal agency of the administration of the United States, stating that we ask to reconsider the plan to send 1 million of satellites around our planet. These satellites are for commercial purposes, for military purposes. They are something that should be understood from the point of view of the consequences of having so much satellites orbiting our planet before the launch, not after. Okay? Let me say something in Italian. Prima che la frittata sia fatta, ok? Before all the eggs are broken. I don't know.
Yes.
Okay, so
more or less.
more or less. So we have to understand the consequences of what we are doing. If we succeed before our actions,
It's
so
always
that
anticipating and foreseeing.
Exactly, so that we have a reasonable idea of the effect of our actions, and this is something that is absolutely overlooked in the case of the so-called mega constellation of satellites. But this is something that is so important that on Monday I will do another meeting online, such as this, with exactly about this topic. Okay,
We might cover it in the future if you want. In the next future, we might cover it with another online meeting.
Okay, you have noticed that I tend to speak a lot. If you have several days that you can spend
to dedicate to you a weekend.
Exactly, the Andrea weekend.
A 2 days online meeting. Okay,
there was another question.
Yes, there was a question from an Afghan student before. Yes, okay, go on, Yalda, please.
Hello, everyone. I have some question. How do the small parts inside a star change how the star grows and lives? And how does this affect planets around it? Thank you.
No, sorry, didn't understand what absorption. Could you repeat the
question?
Could you repeat the first part of the question?
Yeah, why not? How the small parts inside a star change how the star grows and lives, and how does this affect planets around it? Yeah.
So you are curious to understand how the different internal structure of a star affects evolution.
I wanna
and then
know about that, how the star can grow and lives, and why one star have a lot of shine but another then doesn't have. Isn't important for me.
Okay, perfect. All right. Thank you for your question. Sorry because the connection is not so good sometimes. And so the idea, we are talking about two different topics. The one is the appearance of the stars. When we look at the stars with the naked eye, so we can see some stars that are very brilliant, stars that are other stars that are fainter. Okay, this in many cases is due to the different distances of the stars from us. Sirius is the most brilliant star that we can see in the starry night, but is not the more luminous star that we know. More luminous means the star that is emitting more energy in space. Sirius is not so far from us, so we can see a lot of its light arriving to us through space. But there are stars that from Earth we can see like a very faint dot, but maybe this is a wonderful star emitting more light than Sirius, but is also that is farther from us, much farther from us. So thanks to the telescopes, we can understand, analyzing, studying the light coming from the star. If we are looking at a star that is brilliant and luminous, that is emitting a lot of light, and that we can see also with the naked eye very brilliant, or if we are looking at the star that seems faint to us because it is very far, but maybe it is emitting more energy than the sun, more light than Sirius. Just it is farther.
Yeah, also, so you can think of just stars as candles. So, of course, if you have a candle and you put it far away from you, you will see less light. So this is why Sirius, which is a candle really nearby to us, it's very bright. But you were also curious about the interior of the stars. And this means that it's like having different candles. So even if they were all at the same distance, we would see different candles, and you were wondering why maybe one candle is intrinsically brighter than the other one. And you are correct. This depends on what's inside the star. Generally, you would expect that at the beginning, stars are always the same, have the same ingredients: hydrogen, that becomes helium, and then becomes other ingredients. But not all stars are born equal. There are some stars that have more fuel, and some stars that have less fuel. And it is like having different lamps, and you put more or less oil into them, and this means that it can grow a larger flame or a dimmer flame. And it's a lot of complicated physics, but how much fuel they have, how much oil they can burn, impacts, for instance, how big a star will become. And you can have stars that are very, very different. You can think that the sun is already big, but there are stars like Betelgeuse, the one in Orion constellation,
we've talked about,
which is very, very big, thousands times more big than the sun. And this is because it is just burning different. What's inside of her, it is more evolved than the sun. And I cannot explain all the physics to you, but I mean, if you're curious, yeah, I encourage you to look in more deep and to study physics to understand it better. But it's really funny how stars really can be burned. They are born differently because gas collapses, and they just have a lot more to eat when they are born. And then they eat differently the food that they are given, and they grow differently. And this also means that you can see them differently, even if they were at the same distance. And then, as Andrea said, in reality, stars are at different distances. So this also implies that you can see some of them brighter, some of them dimmer, for instance. So it's really a lot of stuff that impacts how we end up seeing them. I don't know if this.
Okay, thanks, Erika. I'm sorry, but the bell is going to ring for the Italian students for the last lesson, so I wanted to greet and thank.
Yeah, exactly. We wanted even to ask to the girls from Afghanistan if they could open the cam just for a sec, just to say hi, and then if you want, if you like to.
If you can.
One more thing, that would be a problem for them to open cams at the moment
Okay,
due to security
no problem.
issues.
Okay, that's no problem.
I'm really sorry for that. I'm really sorry.
No,
Because
don't
of
worry.
security issues, we can't. Yeah.
So nothing. We were leaving, so we wanted to say goodbye and see you next time. Thank you.
Presentation.
Thank you.
Thank you so much. Thank you everyone. Thank you, Corrado. Thank you, Andrea. Thank you, Maria. Thank you for supporting this program and being pulling us together. Yeah, thank you so much.
Okay, thanks everyone for being part of this extraordinary event. First of all, a special thanks, a huge thanks to Andrea and Erika, our special guest, to you, Pashtun, and your dear students, and also thanks for everything. It was great having you. And also thanks to our Scottish colleagues and students who had to leave because there was an issue with a room exchange. Thanks everyone, till next time, enjoy your day.
Thank you, grazie, shukran.
Thank you.
Thank you. Thank you, Andrea. Bye bye. Bye, everyone. The streaming is